Look out your window right now. Look at the glass and steel skyscrapers proudly piercing the sky. Look at the asphalt arteries gripping the earth, the miles of fiber optic nerves buried beneath the concrete, and the glowing screen resting in your hand. You call this a civilization. You call this permanence. You believe that humanity has carved an indelible, physical legacy into the crust of this planet. Now, let the laws of thermodynamics do their work. Press the fast forward button. Not 100 years, not 1,000, fast forward 50 million years into the future. The moment human maintenance halts, entropy begins to tear it all apart. Within mere decades, rainwater infiltrates the microfractures of your greatest monuments, rusting the steel rebar hidden inside massive concrete blocks. The oxidized steel expands, shattering its concrete shell from the inside out. The iconic towers that once defined human engineering collapse under their own dead weight. Within a few millennia, root systems and microbial ecosystems grind the bricks and mortar into mud. Ice ages advance and retreat, scouring the continents like colossal, slow-moving bulldozers made of solid ice. But what about plastics? We produce over 400 million tons of plastic every single year, often dreading it as an eternal catastrophe. The Earth does not share this sentiment. Ultraviolet radiation and polymer-degrading bacteria slowly sever those molecular chains. In the lens of deep time, a few 100,000 years is nothing but a blink. After that brief cycle, the entirety of humanity's plastic waste evaporates from the physical realm, liquefied and absorbed back into the planetary system. Over millions of years, tectonic plates relentlessly shove against one another. The Earth's crust subducts, plunging deep into the molten mantle, boiling coastal cities into magma, while simultaneously twisting ancient plains upward to forge new mountain ranges. The crushing pressure of millions of tons of rock obliterates whatever happens to be trapped underneath. After 50 million years, if you were to return to the exact spot where you are sitting today, you would not find a single wall, a single foundation, or a single ruin. Every architectural geometry, every masterpiece of art, every pinnacle of human metallurgy, all of it crushed, compacted, and fossilized into a mute, 2 millimeter thick chemical sediment trapped between layers of ancient rock. This is not a romantic poem about destruction. This is the result of rigorous mathematical modeling. In 2018, Gavin Schmidt, director of NASA's Goddard Institute for Space Studies, and Adam Frank, a professor of astrophysics at the University of Rochester, published a paradigm-shifting paper in the International Journal of Astrobiology. They were not writing science fiction. They presented a cold, technical problem known as the Silurian hypothesis. If an industrial civilization had existed on Earth tens of millions of years before us, would we even be able to tell? They ran the geological decay models. They calculated the lifespan of every synthetic material under the crushing weight of deep time. And the conclusion they reached was a death sentence to human arrogance. We would not know. Because geological time does not preserve architecture, the Earth is a colossal digestive tract, and it will break down all synthetic matter into its basic elements. There will be no plastic cup, no nuclear reactor core, no shard of smartphone glass left intact for future geologists to dig up and triumphantly declare, "Someone was here." The only thing that survives that ruthless digestive process, the only thing that successfully passes through the 50 million year filter, is chemistry. It is an anomalous ratio of isotopes locked in stone. It is a strange concentration of rare metals in a narrow band of sediment. It is a radical shift in carbon signatures stamped onto the ocean floor. Imagine the surface of this planet as a supermarket checkout scanner. When you pass an item over the scanner, the machine has no eyes. It doesn't care how beautifully the milk carton is designed, how perfectly red the apple is, or how intricately the label is printed. The scanner's laser cuts through all physical aesthetics, stripping away the visual shell to read only one thing: a sequence of black and white stripes, a barcode. That 2 millimeter thick chemical sediment is the barcode of human civilization. Nature does not see our majestic forms. When the Earth's cycle closes, it compresses thousands of years of the brilliant, roaring Homo sapiens into a mute, chemical sequence in the bedrock. A barcode containing raw data on a sudden spike in carbon, a radical shift in surface temperatures, and an extinction horizon. If, in the distant future, the scientists of another intelligent species were to scan the rock layer containing our barcode, what would they see? They would see a sudden chemical fluctuation. They would classify it as a geochemical anomaly. They would list natural causes, debate them in peer-reviewed papers, and ultimately leave an open gap that cannot be fully explained. They would note our entire existence as a bizarre, brief climate event in Earth's history, and then simply turn the page. But the cruelty does not end with us becoming an anonymous barcode. The truth that currently sends shivers through the academic machine lies in the exact opposite direction. Because when our scientists drilled deep into the ocean's sedimentary layers, turning over rocks dated to 56 million years ago to analyze them, they dragged their laser scanner across geological time, and the machine beeped. They found a sediment layer, a sequence of numbers, a chemical barcode, and the barcode, compressed inside that ancient rock, dating back 56 million years, before primates even learned to walk on two legs, carries the exact same technical parameters, isotopic ratios, and scale of destruction as the barcode our industry is carving into the Earth today. Let us open the ledger of the Earth's deep history. We are not looking for grand ruins, for crumbled statues, or the rusted husks of ancient machines. As we have established, the planetary grinder has already pulverized physical forms into nothingness. Instead, we are looking for the barcode. We are looking for chemistry. To find it, paleoclimatologists do not dig in the desert, they drill into the abyss. Using specialized research vessels, scientists plunge hollow titanium tubes thousands of meters through the crushing pressure of the ocean to extract sediment cores from the seafloor. These cylinders of mud and rock are the hard drives of the Earth. Within them lie the microscopic calcium carbonate shells of benthic foraminifera single-celled organisms that lived and died millions of years ago, absorbing the exact chemical composition of the seawater into their shells before drifting to the bottom to become stone. When scientists extract these cores from the Atlantic, the Pacific, the Indian, and the Southern Oceans, and read the geological strata dating back to approximately 56 million years ago, they do not find a steady, undisturbed progression of time. They find a violent, localized trauma. The event is catalogued in the scientific literature as the Paleocene-Eocene thermal maximum, abbreviated as the PETM. It is one of the most thoroughly documented, universally replicated, and relentlessly studied phenomena in the history of paleoclimatology. The basic parameters of this event are not a matter of debate. They are physical facts locked into the global stratigraphic record. 56 million years ago, in a window of time so narrow that geologists consider it an instant, roughly a few thousand years, between 3 and 7 trillion tons of carbon were violently injected into the Earth's atmosphere and oceans. The planetary system reacted exactly as the laws of thermodynamics dictate. Global temperatures skyrocketed by 5 to 8 degrees Celsius. The sudden influx of carbon dioxide dissolved into the oceans, radically altering the water's pH balance in a process known as ocean acidification. The deep-sea ecosystems, which had been perfectly adapted to stable conditions for millions of years, were thrown into toxic shock. A third of all species living on the ocean floor were suffocated and exterminated. The Earth was pushed so far beyond its thermal equilibrium that it triggered a complete biological and climatic reset. But the most terrifying data point regarding the PETM is not the temperature spike, nor is it the extinction rate. It is the recovery time. It took the Earth approximately 200,000 years to scrub that excess carbon from the atmosphere, cool the oceans, and return the climate to a state of equilibrium. 200,000 years. To comprehend the weight of that number, consider that anatomically modern humans, Homo sapiens, have only existed for roughly 300,000 years. The entire span of our species' existence, from the first spark of fire in a Pleistocene cave to the launching of satellites into orbit, barely eclipses the amount of time it took the Earth to recover from a single carbon event. The planet did not panic. It did not mourn the extinguished deep-sea life. The Earth is a self-balancing thermodynamic engine. When an overload of energy is introduced into the system simply shifts its state, absorbs the shock, and takes 2,000 centuries to slowly bury the carbon back into the rock through the weathering of mountains and the slow accumulation of biological debris. The Earth always balances the equation. The entities caught in the middle of that balancing act simply become fossils. But what exactly burned? What source could possibly unleash 3 to 7 trillion tons of carbon in a geological heartbeat? To answer that question, we must look away from the macro scale of global extinction and zoom in on the subatomic structure of the universe. We must look at the atom, because the carbon that triggered the PETM was not generic, it carried a highly specific identity. To understand the PETM, you only need to understand one fundamental law of chemistry. The rest of the mystery unravels automatically. Carbon, the foundational building block of life on this planet, exists in 2 stable, isotopic forms. Scientists refer to them as carbon-1,2 and carbon-1,3. The difference between them is agonizingly small. They possess the same number of protons, but carbon-1,3 carries 1 additional neutron in its nucleus. Carbon-1,2 is the lighter version. Carbon-1,3 is the heavier version. Both exist naturally in the environment, but the ratio between them is the ultimate sorting mechanism of the natural world. Biology is fundamentally an engine of efficiency. It always seeks the path of least resistance. When a plant photosynthesizes, or when a microorganism consumes nutrients, its biological enzymes, specifically an enzyme called rubisco, must capture carbon dioxide from the air or water to build physical tissue. Because carbon-1,2 is slightly lighter, it requires marginally less kinetic energy to process. Therefore, life inherently discriminates. Every plant, every animal, every bacterium, every blade of grass, and every forest on Earth preferentially filters and absorbs the lighter carbon, 1,2 isotope, into its cellular structure. This creates a rigid, unbreakable law of planetary chemistry. Anything that is currently alive, or anything that was once alive, is heavily enriched in the light isotope carbon-1,2. When forests are buried under sediment and subjected to millions of years of heat and pressure, they transform into peat, coal, oil, and natural gas. These fossil fuels are simply the compressed, liquefied corpses of ancient biology. Consequently, they are packed with carbon-1,2. Volcanic carbon, by stark contrast, originates from the deep, molten mantle of the Earth. It has never been processed by a leaf, a lung, or a cell. It has no biological history. Therefore, carbon outgassed from volcanoes or tectonic rifts carries a heavier isotopic signature, reflecting the natural, inorganic background ratio of the planet's interior, a higher proportion of carbon-1,3. These 2 sources of carbon are as distinguishable from one another as 2 distinct blood types. You cannot confuse them, you cannot fake them. When a forensic investigator walks into a pristine, empty room where a crime has been committed, the furniture may be gone, the weapon may be missing, and the bodies may have been dissolved. But if the perpetrator touched the glass window, the oils from their skin leave behind a unique pattern of ridges, a fingerprint. It is a biological signature that cannot belong to anyone else. The Earth's strata operate on the exact same principle. When the scientists analyzed the microscopic shells in the sediment cores from the PETM boundary layer 56 million years ago, they did not just measure the amount of carbon, they ran it through a mass spectrometer to measure the weight of the carbon. What they found was a massive, globally synchronized negative carbon isotope excursion every single measurement, taken across 30 years of relentless research from every major ocean basin on the planet, confirmed the exact same reality. The 3 to 7 trillion tons of carbon that flooded the atmosphere and triggered one of the most severe climate disruptions of the past 66 million years was overwhelmingly composed of carbon 1-2. It was isotopically light. It was organic in origin. The carbon that choked the oceans and spiked the temperature of the Earth 56 million years ago carries the unmistakable, undeniable chemical fingerprint of burned or rapidly decomposed biological material. Not volcanic rock, not a slow, deep earth tectonic process, something that was once alive. The evidence is not ambiguous. It is not a fringe theory. It is a locked data point in the center of mainstream geology, a biological fingerprint sitting on the geological trigger of a mass extinction. And in the next run, we will apply the ruthless logic of mathematics to prove why every natural explanation the textbooks offer to explain this fingerprint mathematically collapses under its own weight. The geological record has presented a physical fact. 56 million years ago, a colossal volume of isotopically light carbon, the unmistakable chemical fingerprint of organic matter, was violently injected into the Earth's atmosphere. Faced with this data, the natural sciences must balance the equation. In any closed thermodynamic system, matter cannot be conjured from the void. If 3 to 7 trillion tons of biological carbon suddenly materialized in the atmosphere over a geologically instantaneous window of a few thousand years, it had to come from a physical reservoir on the Earth. Here is the question that the textbooks handle with extreme care, wrapping it in layers of cautious academic prose, but never quite managing to answer what biological source on Earth was large enough to release that volume of isotopically light carbon in such a microscopic fraction of geological time. The standard paleoclimatology models offer 3 natural candidates to solve the equation. We will subject each one to the unforgiving scrutiny of mathematics. Candidate 1. Volcanic activity. Around the onset of the Paleocene-Eocene thermal maximum, PETM, the Earth was undergoing a massive tectonic restructuring. A colossal igneous province was erupting in what is now the North Atlantic, associated with the violent geological rifting that was tearing Greenland away from northern Europe. These eruptions were planetary in scale, sustained over tens of thousands of years, and they unquestionably released staggering quantities of carbon dioxide into the atmosphere. However, logic dictates that the mechanism must match the evidence. Volcanic carbon originates from the molten rock of the Earth's mantle. It has never seen the sun. It has never been processed by a living cell. Therefore, volcanic carbon carries the heavy isotopic signature, heavily weighted toward carbon, 1-3. It completely contradicts the light. Carbon 1-2 fingerprint of the PETM. Did the North Atlantic eruptions contribute to the event? Absolutely. The initial outgassing likely provided the baseline warming that triggered secondary planetary mechanisms. But volcanic activity cannot be the primary source of the isotopically light carbon that mathematically defines the PETM. The first candidate is disqualified by its own atomic weight. Candidate 2. Methane hydrates. Vast quantities of methane are stored in the dark, freezing depths of the ocean floor, trapped in lattice-like crystalline structures of water ice. These are known as methane hydrates. They exist in a fragile state of equilibrium, held stable only by the crushing pressure of the deep ocean and the near-freezing temperatures. Methane is an incredibly potent greenhouse gas, and crucial to this investigation, its carbon is biologically derived. It is the byproduct of microbial decomposition in the sediment. It carries the light, carbon 1,2 fingerprint. If the oceans warmed sufficiently, perhaps triggered by the initial volcanic activity, these frozen deposits could destabilize, thawing rapidly and releasing enormous volumes of biological methane into the water column and the atmosphere. This mechanism perfectly fits the isotopic signature, and it perfectly fits the speed of the release. It is universally accepted as a major component of the PETM, but physics requires the numbers to balance. When researchers build precise computational models to calculate the maximum total volume of methane that could have realistically been stored in the known and estimated hydrate reservoirs 56 million years ago, they hit a mathematical wall. The models simply cannot generate enough methane to account for the full 3 to 7 trillion tons of carbon recorded in the ocean sediment. Even if every single ounce of frozen methane on the seafloor suddenly boiled into the atmosphere simultaneously, the ledger remains deep in the red. Candidate 3. Thermal decomposition of organic sediments. When magma from deep volcanic intrusions violently penetrates upper layers of carbon-rich sedimentary rock, the extreme heat can bake the organic material trapped inside, effectively cooking it and rapidly releasing methane and carbon dioxide. This mechanism produces isotopically light carbon, and it was undoubtedly active in the North Atlantic during the volcanic rifting. It contributes a meaningful volume of carbon, 1/2 to the total atmospheric budget. But like the methane hydrates, when subjected to rigorous volumetric calculation, it hits a hard ceiling. It does not close the gap entirely. Now we execute the final calculation. Add up every single known natural source. Combine the heavy carbon of the volcanic outgassing, the light carbon of the thawing methane hydrates, and the baked carbon of the thermal sedimentary decomposition. Maximize the parameters of every natural model. The total still falls short. The volume of isotopically light carbon permanently recorded in the geological strata vastly exceeds what the combined natural mechanisms of the planet can produce. This mathematical shortfall is not a secret. It has been noted, documented, and discussed in the published scientific literature for 30 years. It is a recognized void in the explanation of the most intensely studied, rapid climate event in Earth's history. The academic institution responds to this void not with conspiracy or suppression, but with the cold inertia of systemic caution. Scientists describe the gap using highly technical, sterilized language. They refer to additional carbon sources that have not been fully identified. They write careful footnotes, noting that the climate models are sensitive to assumptions about initial boundary conditions. They meticulously catalog the anomaly, publish the papers, secure their funding for the next baseline study, and leave the gap officially open. 30 years of research. Thousands of peer-reviewed papers. The most comprehensively studied carbon anomaly in the geological record. And the books do not balance. When the natural mechanisms of the planet cannot mathematically account for the rapid, planetary-scale combustion of biological energy, only one other thermodynamic mechanism remains: the rapid, planetary-scale combustion of stored organic energy, coal, oil, and gas, driven by an external force, the exact mechanism of an industrial engine. This is the inescapable logic that makes Gavin Schmidt and Adam Frank's 2018 Silurian hypothesis so devastating. They proved that if a civilization exactly like ours existed 56 million years ago, burned through the planet's fossil fuels, and collapsed, we would not find their cities. We would only find a massive, unexplained volume of isotopically light carbon delivered with unnatural speed, leaving a permanent gap in the geological ledger. We would find exactly what we see in the PETM. The planet is a grinder, and it has already digested the physical forms of whatever triggered that event. The chemical barcode has been read. It is a biological fingerprint attached to a volume of destruction that natural processes cannot fully claim. But chemistry is only the first layer of the Earth's memory. To understand the true hostility of the environment we inhabit, we must leave the silent, invisible world of carbon isotopes and move into the realm of violent, physical trauma. We must look at what happens when the planetary grinder does not wait millions of years to slowly erase a species, but decides to execute the deletion in a single, blinding flash of kinetic energy. We must examine the scars of the sky. Let us advance the timeline. We move forward from the deep, 5-6 million year old chemical abyss of the PETM and arrive at a much more recent geological horizon. We step into the late Pleistocene epoch, approximately 12,800 years before the present. The Earth was in a state of transition. The relentless grip of the last glacial maximum was finally loosening. The colossal ice sheets that had suffocated much of North America and Northern Europe beneath miles of frozen water for tens of thousands of years were in rapid retreat. The global temperature was rising. Forests were aggressively reclaiming territories that had been barren tundra. The planetary thermodynamic engine was shifting into a warmer, more permissive interglacial phase. Upon this thawing landscape, biological systems were flourishing, maximizing their energy consumption. The apex of this biological expansion was the megafauna. North America was a roaming ground for colossal biological engines. Woolly mammoths, mastodons, giant ground sloths standing as tall as modern trees, short-faced bears, and saber-toothed cats. They were the dominant biological consumers of their era, perfectly adapted to their ecosystems, having successfully survived multiple previous climate oscillations over hundreds of thousands of years. Alongside them moved a relatively new, highly efficient catalyst species, the Clovis culture. The Clovis people were the first clearly identifiable, widespread human culture in the Americas. They were not a struggling, marginal population clinging to the edge of survival. They were a thriving, continent-spanning network of apex predators. Their technology, specifically, the elegantly fluted Clovis stone spear points, represented a zenith of prehistoric engineering, allowing them to extract maximum caloric energy from the megafauna. From the subarctic regions of Canada to the tip of South America, their artifacts paint a picture of a species that had successfully conquered its environment. They possessed the illusion of absolute mastery. And then, in a geological window so narrow that stratigraphy cannot distinguish it from a single, isolated moment, the illusion shattered. Everything reversed. The warming stopped instantaneously. Global temperatures plummeted, snapping the planet back into severe glacial conditions. This abrupt climate anomaly is known as the Younger Dryas. It was a brutal, freezing shock that lasted for roughly 1,200 years. But the temperature drop is only the background context. The true violence lies in the biological deletion. Within the span of a single human generation, the distinctive, highly successful Clovis tool technology entirely vanishes from the archaeological record. It does not slowly evolve into a different style. It does not migrate. It simply ceases to exist. One stratigraphic layer, they are there, the masters of the continent. The next layer, they are gone. Simultaneously, the megafauna were exterminated. The mammoths, the mastodons, the giant sloths, the dire wolves, the entire upper echelon of the North American food web were wiped out. The standard academic consensus, driven by the innate human desire to place our own species at the center of every planetary narrative, proposes the overkill hypothesis. This model argues that the Clovis hunters were simply too efficient. They hunted the megafauna at a rate that exceeded biological reproduction. They drove the great beasts to extinction, which subsequently caused a catastrophic collapse of the food web, eventually leading to the starvation and disappearance of the Clovis culture itself. It is a coherent, deeply moralistic story about human hubris and ecological overshoot. It is exactly the kind of narrative the human ego prefers, because even in destruction, it grants us agency. It says, "We were the cause," but the mathematics of the overkill hypothesis collapse the moment they are subjected to rigorous physical logic. Biological extinction driven by hunting pressure is inherently a gradual, generational process. Overhunting leaves a very specific, readable trail in the archaeological record. It shows declining animal populations over centuries. It shows human populations slowly shifting their dietary strategies, transitioning to smaller game as the larger prey becomes scarce. It shows cultural adaptation. The Clovis disappearance shows none of this. It is a hard, abrupt, stratigraphic boundary. Furthermore, the geographic logic of the overkill hypothesis is a physical impossibility. The extinctions of 12,800 years ago were not confined to North America. In the exact same narrow window of time, woolly mammoth populations across Eurasia suffered catastrophic declines. The large fauna in South America experienced parallel extinctions. Megafaunal systems across Australia showed severe disruptions in the same geological instant. We are looking at a synchronized pattern of mass death, repeating across multiple disconnected ecosystems. There was no shared human population between these continents. There was no mechanism for transmitting a hunting strategy from a Clovis tribe in what is now Arizona to an isolated mammoth herd in the Siberian tundra. Hunting pressure is, by the laws of physics, a localized force. Synchronized global deletion requires a synchronized global cause, an external force that does not care about oceans, continents, or biological boundaries. When the anthropologists failed to balance the equation, the physicists and geologists stepped in. In 2007, a multidisciplinary team of 26 researchers published a paper analyzing the specific sediment layer corresponding to the 12,800-year boundary across North America. They were not looking for spearheads or fossilized bones. They were looking for the raw physics of the boundary layer itself. What they found completely obliterated the localized overkill model. Buried in the exact same stratigraphic layer, a dark, carbon-rich band, often referred to as the black mat. They discovered an array of anomalous materials that simply cannot be generated by human hunters, melting glaciers, or terrestrial climate shifts. First, they found nanodiamonds. These are microscopic crystals of carbon, some merely billionths of a meter across. You cannot synthesize a nanodiamond in a campfire. You cannot forge one in a forest fire, a flood, or a volcanic eruption. To force carbon atoms into the cubic lattice structure of a diamond requires instantaneous, catastrophic levels of extreme pressure and temperature parameters that are exclusively associated with the hypervelocity impact of an extraterrestrial body. Second, they extracted magnetic microspherules. These are tiny, perfectly formed spheres of iron and other metals. They are created when solid rock is vaporized by thousands of degrees of kinetic heat, lofted high into the stratosphere, and then rapidly cooled into aerodynamic droplets as they rain back down upon the Earth. Third, they detected a highly localized enrichment of iridium. Iridium is an element that is incredibly rare on the surface of the Earth, as most of it sank into the planet's molten core during its formation. It is, however, highly abundant in asteroids and comets. Finding an iridium spike in a thin layer of sediment is the ultimate cosmic signature. It is the same signature used to identify the dinosaur-killing asteroid of 66 million years ago, albeit on a different scale. Fourth, they documented shocked quartz. These are grains of standard silica whose internal crystalline structure has been violently fractured and deformed along parallel planes. This deformation requires kinetic shock pressures, far exceeding the capabilities of any terrestrial geological process. Finally, alongside these exotic impact markers, the researchers documented massive, overwhelming concentrations of charcoal and soot. Not the residue of localized campfires, but the chemical footprint of synchronized continental-scale firestorms. These markers were not found at a single, isolated site. As research expanded over the next 15 years, this exact combination of impact proxies, nanodiamonds, microspherules, iridium, shocked quartz, and continental soot was replicated and verified at over 50 separate locations across 4 continents: North America, Europe, Asia, and the Middle East, all locked in the exact same stratigraphic layer, all dated to the exact same narrow window around 12,800 years ago. The Earth's surface is not a nurturing mother. It is an exposed target. To understand the reality of what this data represents, we must strip away the academic terminology and look at it through a lens of pure mechanical violence. Imagine a massive, catastrophic collision between 2 high-speed machines on an asphalt highway. The kinetic energy destroys both vehicles instantly. In the aftermath, emergency crews arrive. They tow the crushed metal away. They wash the blood and oil from the pavement. The highway is cleared, and within weeks, thousands of other cars are driving over that exact same spot, completely unaware that the violence ever occurred. The physical forms of the accident have been erased. But if you were to walk onto that highway at night, get down on your hands and knees, and shine a bright flashlight directly against the black asphalt, you would see it. Embedded deep within the tar, pressed into the pavement by the crushing force of the impact, are thousands of tiny, glittering shards of shattered glass. They are impossible to remove. They are permanent proof of the kinetic trauma. The nanodiamonds, the magnetic microspherules, and the iridium anomalies scattered across 4 continents are not archaeological mysteries. They are the shattered glass on the highway. 12,800 years ago, the sky crashed into the Earth. An extraterrestrial object, a fragmented comet, or an asteroid slammed into the northern hemisphere at tens of kilometers per second. The biosphere did not slowly starve due to human overhunting. It was flash incinerated, suffocated, and pulverized by atmospheric shockwaves, continental firestorms, and a sudden, violent plunge into impact winter darkness. The shattered glass is still there, glittering in the sediment, proving that the collision was real. But the scientific establishment's reaction to this shattered glass reveals a mechanism of human psychology that is just as cold and predictable as thermodynamics. In the next run, we will examine the physical crater that was hiding beneath the ice, and we will dissect exactly why the academic machine fought so relentlessly to ignore the shrapnel embedded in our planet's skin. The physical evidence scattered across the Younger Dryas boundary layer, the nanodiamonds, the magnetic microspherules, the iridium anomalies, and the shocked quartz presented a localized problem for the scientific establishment. The data itself was robust. Mass spectrometers do not lie, and electron microscopes do not fabricate crystalline deformations. The physical reality of the shattered glass embedded in the sediment across 4 continents was undeniable. However, in the discipline of geology, a fragmented cosmic collision is an incomplete equation without a point of primary impact. If a celestial body possessing enough kinetic energy to flash freeze a hemisphere and ignite continental firestorms had indeed struck the Earth 12,800 years ago, it should have left a corresponding scar. It should have left a crater. For over a decade after the initial publication of the Younger Dryas impact hypothesis in 2007, the critics held a singular, devastating counterargument. Where is the hole? Without a crater, the impact hypothesis remained. In the eyes of mainstream academia, a fringe theory, a dramatic speculation built on microscopic anomalies rather than macroscopic proof. The inertia of the established overkill hypothesis and the meltwater pulse climate models held firm, primarily because they did not require the introduction of a sudden, catastrophic variable. They were safe, gradual, and terrestrial. But the Earth is a master of concealment. It operates on a scale that dwarfs human perception. A crater capable of ending the Pleistocene epoch would not necessarily look like a neat bowl carved into a desert floor. It could be swallowed by the ocean, subducted beneath tectonic plates, or, most terrifyingly, buried beneath the very element it displaced. In 2018, the missing variable was found. It was not discovered by archaeologists digging in the dirt. It was identified by glaciologists and radar engineers scanning the most inhospitable environment on the planet. An international team led by researchers from the Natural History Museum of Denmark was analyzing airborne radar data collected by NASA's Operation Icebridge. They were mapping the bedrock topology hidden beneath the colossal Hiawatha Glacier in northwestern Greenland. When they processed the radar echoes bouncing off the rock beneath a kilometer of solid ice, the topography did not show the expected jagged peaks and valleys of a standard glacial landscape. It revealed a perfect, circular depression. The Hiawatha impact crater is a massive structural anomaly measuring 31 kilometers, 19 miles in diameter. It is carved deep into the ancient bedrock, featuring a distinct, elevated central peak, the classic rebound signature of a hypervelocity impact, where the Earth's crust briefly behaved like a liquid drop, reacting to a massive stone thrown into it. To create a crater 31 kilometers wide, the physics require an iron-rich asteroid approximately 1.5 kilometers, almost a mile wide, striking the Earth at a velocity of 20 kilometers per second. The kinetic energy released upon impact would have been equivalent to detonating 47 million Hiroshima-sized nuclear bombs simultaneously. If this object struck the thick Laurentide ice sheet that covered much of North America and Greenland 12,800 years ago, the sequence of events aligns perfectly with the thermodynamic chaos of the Younger Dryas. The instantaneous release of energy would have vaporized millions of tons of solid ice in a fraction of a second, blasting a colossal volume of superheated water vapor and pulverized rock high into the stratosphere. The shockwave would have radiated outward, flattening forests across the hemisphere and igniting the continental firestorms evidenced by the soot layers. The massive influx of vaporized fresh water injected directly into the North Atlantic would have violently disrupted the ocean's thermohaline circulation, the global conveyor belt of warm water. The shutdown of this current, combined with the atmospheric blocking of sunlight by the ejected debris, would have plunged the northern hemisphere back into deep glacial conditions with brutal, terrifying speed. And, crucially, the impact would have synthesized and scattered the exact cocktail of high-pressure impact proxies, the nanodiamonds and the iridium found in the boundary layer across the globe. The discovery of the Hiawatha crater provided the missing macroscopic anchor. The equation was finally balanced. The shattered glass on the highway now had a corresponding wrecked vehicle. Yet, the reaction from the broader academic establishment was not a sudden, unified paradigm shift. It was not a collective realization that the textbooks needed immediate rewriting. Instead, the reaction was a masterclass in institutional inertia. The debate simply shifted. Critics argued about the dating of the crater, suggesting it might be much older, perhaps millions of years old, despite the remarkably uneroded state of its structural rim beneath the flowing ice. They demanded more cores, more radar passes, more localized isotopic analysis. The integration of the impact hypothesis into the mainstream consensus proceeded at a glacial pace, met with resistance at every institutional checkpoint. To a layperson, this resistance might look like a conspiracy, It might look as though scientists are actively suppressing the truth to protect their own reputations or to maintain a specific historical narrative. But applying the label of conspiracy is a profound misunderstanding of how the academic machine actually operates. There is no secret cabal of geologists meeting in dark rooms to hide the existence of comets. The reality is far more mundane and, in a way, far more chilling. The resistance is systemic. It is an emergent property of the academic structure itself. Science, as an institution, is inherently conservative. It is designed to resist sudden shifts. This is generally a protective mechanism, preventing the entire body of human knowledge from pivoting wildly every time a new, unproven theory is proposed. But this conservatism becomes a trap when faced with data that genuinely demands a radical restructuring of the baseline. Consider the mechanics of an academic career. A professor of archaeology may have spent 30 years building their reputation, securing grants, publishing papers, and mentoring doctoral students based entirely on the premise of the overkill hypothesis. Their entire professional identity, their tenure, and their funding streams are inextricably linked to the idea that human hunters slowly drove the mammoths to extinction. When a team of physicists arrives with a handful of nanodiamonds and a radar scan of a crater in Greenland, claiming that the biosphere was actually deleted in a single afternoon by a space rock, the archaeologist is not just being asked to change their mind. They are being asked to invalidate 3 decades of their own life's work. They are being asked to admit that the foundational premise of their funding was flawed. Furthermore, the structure of academic funding inherently punishes risk. Grant committees allocate limited resources. They prefer proposals that build incrementally upon established consensus-safe research that guarantees a predictable, peer-reviewed publication. Proposing a study to investigate the specific mechanics of a controversial comet impact is career suicide for a young researcher. If the study fails to produce definitive results, the researcher is labeled a fringe scientist, and their access to future funding is severed. The scientists are not malicious. They are simply operating rationally within a system that penalizes deviation. They choose the safety of the textbook because the textbook pays the mortgage and secures the tenure. But there is a deeper, psychological layer to this institutional inertia. Accepting the overkill hypothesis, or even the gradual climate shift models, allows humanity to maintain a comforting illusion of control. It suggests that the Earth is a stable, predictable environment, and that extinctions are the result of biological interactions that we can understand and perhaps manage. It keeps the threat terrestrial. Accepting the Younger Dryas impact hypothesis shatters that illusion completely. It forces the human mind to confront a terrifying thermodynamic reality. The sky is an active firing range. If we acknowledge that an object a mile wide can drop from the darkness of space without warning, instantly delete the dominant species on the continent, and reset the climate of the entire planet in a matter of hours, we must also acknowledge our own absolute vulnerability. It means that all of our cities, our technologies, and our carefully constructed geopolitical systems exist solely at the mathematical mercy of orbital mechanics. We are not the masters of our environment. We are simply squatters living in the brief, quiet intervals between celestial bombardments. The academic machine resists the impact data, not because they are hiding the truth, but because the truth is existentially intolerable. It is easier to debate the dating of a crater than to look up at the night sky and accept that it is a loaded weapon. However, the Earth's memory is not limited to what falls from the sky. The planetary grinder has other mechanisms for erasure mechanisms that do not rely on kinetic shockwaves, but on the slow, suffocating rise of an unstoppable force. While the northern hemisphere was burning and freezing, the boundaries of the continents themselves were being rewritten by a much quieter, yet equally devastating power. We must now turn our attention from the shattered glass of the impact to the slow violence of the oceans. We must examine the phantom limbs of human history. The planetary grinder has many speeds. The extraterrestrial impact that initiated the Younger Dryas was an execution measured in seconds, an injection of kinetic energy so violent it left microscopic shrapnel embedded in the Earth's crust. But the Earth also possesses mechanisms of deletion that operate with agonizing, unstoppable slowness. When the fires burned out, and the impact winter eventually yielded to the overarching warming trend of the Holocene epoch, the thermodynamic engine of the planet shifted gears. The Earth began to process a massive phase transition. Solid water had to become liquid. At the height of the last glacial maximum, the planet's oceans were vastly depleted. Millions of cubic kilometers of water were locked in colossal continental ice sheets. The Laurentide ice sheet smothered North America beneath a dome of ice up to 3 kilometers thick. The Fennoscandian ice sheet crushed northern Europe. The sheer mass of this frozen water physically depressed the continental crust, pushing the bedrock deep into the Earth's mantle. Because so much of the planet's water was trapped in these frozen mountains, the global sea level was drastically lower than it is today. The coastlines of the Pleistocene epoch did not look like the maps we navigate by now. The continental shelves, the shallow, gently sloping perimeters of the landmasses, were fully exposed to the air. For early humanity, these exposed shelves were not marginal territories. They were the absolute center of the biological world. Coastal plains offer the highest caloric density on the planet. They provide estuaries teeming with marine life, temperate climates, and flat, fertile hunting grounds. From an evolutionary and thermodynamic standpoint, a species seeking to maximize its energy intake will inevitably cluster along the coasts. The deep interiors of the continents, plagued by extreme weather and rugged terrain, were the fringes. The coasts were the capital cities of the prehistoric world. Then, the thermodynamic balance tipped. The ice began to melt. Between 15,000 and 7,000 years ago, the global sea level rose by a staggering 120 meters. 120 meters. 400 feet. It is easy to read that number on a page, but the human brain struggles to comprehend the sheer scale of the physical displacement it represents. To visualize this, imagine standing on the shoreline of your favorite beach today. Now, imagine a wall of water as high as a 40-story skyscraper. That is the volume of water that was systematically transferred from the glacial poles to the world's oceans. This was not a localized flood. It was a global reshaping of the planet's surface area. This phase transition was not a smooth, gentle creeping of the tides. The melting of continental ice sheets is a chaotic, non-linear process. The geological record reveals periods of terrifying acceleration known as meltwater pulses. The most violent of these, Meltwater Pulse 1A, occurred roughly 14,000 years ago. As the ice sheets destabilized, colossal glacial lakes holding thousands of cubic miles of fresh water, such as Lake Agassiz in North America, burst through their ice dams. The hydrostatic pressure catastrophically fractured the retaining walls, flushing unimaginable volumes of water into the ocean in a matter of months. During Meltwater Pulse 1A, the global sea level spiked by up to 20 meters, 65 feet, in the span of just a few centuries. For the biological organisms living on the coastal plains, this was a waking nightmare. The ocean did not just rise, it marched inland. In areas with highly gradual topographic slopes, a vertical rise of 1 meter can translate to several kilometers of horizontal land loss. Entire ecosystems, forests, and human hunting grounds were swallowed by encroaching saltwater, turning into brackish marshes before disappearing entirely beneath the waves. This was not merely a change in scenery, it was a geographic amputation. The Earth was systematically amputating millions of square kilometers of its most habitable, energy-dense biosphere. We can map the missing limbs. In northern Europe, between the modern-day eastern coast of Great Britain and the mainland coasts of the Netherlands and Germany, there once existed a vast, thriving landmass known as Doggerland. It was not a barren wasteland. It was the ecological heart of Pleistocene Europe, a gently rolling plain of lagoons, marshes, and forests, heavily populated by mammoths, deer, and human hunter-gatherers. Today, Doggerland is the bottom of the North Sea. It was entirely deleted from the terrestrial map. The only reason we know it existed is because modern industrial trawlers, dragging heavy nets across the seafloor, occasionally pull up the physical residue of this drowned world. Mammoth femurs, ancient tree stumps, and flawlessly crafted stone tools, dripping with cold salt water. In Southeast Asia, a massive subcontinent known as Sunderland connected modern-day Thailand, Malaysia, Sumatra, Java, and Borneo into a single, colossal landmass. It was a tropical paradise, representing one of the largest continuous habitats for human expansion on Earth. When the ice melted, the ocean amputated Sunderland, drowning the plains and leaving behind only the highest mountain peaks, which we now recognize as the scattered archipelagos of Indonesia and the Philippines. The same amputation occurred globally. The Bering Land Bridge was severed. The Persian Gulf, once a fertile river valley, was flooded by the Indian Ocean. In total, a landmass roughly equivalent to the size of Europe and China combined was swallowed by the sea. This mechanical reality presents a massive, nearly insurmountable problem for modern science. Archaeology is a terrestrial discipline. It relies on humans walking across deserts, digging into hillsides, and mapping caves. We have built our entire understanding of human history based on what we find on dry land. But if the fundamental laws of biology dictate that prehistoric humans would have concentrated their populations on the fertile coastal plains, and the fundamental laws of geology dictate that those exact plains are now submerged beneath 120 meters of crushing, opaque saltwater, then the conclusion is mathematically grim. We are not looking at the center of ancient human civilization. We are looking at the refugees. The ruins we find on high ground today are merely the remnants of populations that lived on the fringes of the Pleistocene world. The true epicenters of human development, the places where they had the most time, the most calories, and the greatest stability to develop complex societies, have been locked away in a vault that we cannot access. Underwater archaeology is paralyzed by logistics. Salt water is a highly corrosive solvent. Ocean currents scatter artifacts. Silt and marine sediment bury structures at an accelerated rate. To excavate a site at a depth of 40 meters requires specialized diving teams, pressurized equipment, and exponential funding. To excavate at 120 meters is practically impossible for standard historical research. When anomalous underwater structures are discovered, such as the massive, geometrically cut stone terraces off the coast of Yonaguni, Japan, or the acoustic sonar shadows resembling city grids in the Gulf of Kambat off the coast of India, they are routinely dismissed or categorized as natural geological formations. The academic machine defaults to the safest explanation, not because they are certain, but because proving otherwise requires breaching an impenetrable vault. The ocean is the ultimate shredder of evidence. The physical land is gone, the biological habitats are gone, the archaeological data is gone, but while the physical forms were erased by the rising water, the psychological trauma of that erasure could not be dissolved by the ocean. The human mind, operating as a biological recording device, captured the terror of the encroaching sea and compressed it into a format that could survive the amputation. In the next run, we will examine the psychological scars left by this event. We will analyze how the memory of the drowned world defied time, manifesting as a collective neurological symptom across the entire human species. When a human being suffers a catastrophic physical trauma, such as the amputation of an arm or a leg, the healing of the physical wound does not equate to the healing of the neurological system. The severed nerves often continue to send desperate, misfiring signals to the brain. The patient will swear they can feel the fingers of the hand they no longer have. They will feel itching, burning, and severe pain in an appendage that is physically absent. In medical science, this is diagnosed as phantom limb syndrome. It is the neurological residue of trauma. It is the brain's inability to accept that a fundamental part of its reality has been abruptly deleted. If we scale this neurological phenomenon up from a single individual to the entire collective consciousness of Homo sapiens, we find a perfect analogue for what occurred after the meltwater pulses amputated the coastal plains. The human species suffered a collective geographic amputation. The most fertile, population-dense regions of our world were severed from us. And just like a patient waking up from a traumatic surgery, the collective human mind could not simply accept the loss and move on. The psychological shock was too profound. The memory of the drowned world became the phantom limb of humanity. This phantom limb did not manifest as physical pain. It manifested as a story. A very specific, recurring, and inescapable story. If you survey the anthropological and mythological records of human cultures across the globe, you will encounter a statistical anomaly that defies all logic of independent cultural development. There are over 500 distinct flood myths recorded across unconnected civilizations. We are not talking about generic stories of localized river flooding. We are talking about a highly structured, remarkably consistent narrative architecture. A thriving, perhaps corrupted or ignorant former world exists. A catastrophic, apocalyptic deluge is unleashed. The waters rise to swallow the land entirely. A very small fraction of the population survives, usually by building a vessel or retreating to the highest peaks. They inherit a completely reshaped, diminished world. This core narrative structure is found in the Epic of Gilgamesh from ancient Mesopotamia. It is found in the biblical story of Noah. It is etched into the Hindu texts concerning Manu. It is woven into the oral traditions of the indigenous tribes of North America, the aboriginal cultures of Australia, and the ancient mythologies of Mesoamerica. These cultures were separated by vast, uncrossable oceans and tens of thousands of years of independent development. Yet, they all share the exact same scar. When a forensic pathologist walks into a room containing 500 different people from 500 different countries and discovers that every single one of them bears an identical scar slashed across their wrist in the exact same location, the pathologist does not conclude that this is a coincidence. The pathologist concludes that all 500 individuals were subjected to the exact same traumatic event. The 500 flood myths are not fairy tales. They are not the result of early humans lacking the scientific vocabulary to explain seasonal monsoons. They are the compressed, traumatized memory of the meltwater pulses. They are the shared scar of the human species. For the generations that survived the rapid sea level rise 14,000 years ago, the trauma was absolute. Imagine being a hunter-gatherer living on the plains of Doggerland or Sunderland. The ocean is not a distant concept, it is the boundary of your world. When that boundary begins to violently march inland, swallowing your hunting grounds, your sacred sites, and your ancestral burial mounds, you do not have the geological context to understand melting ice sheets. You only know that the world is ending. As they fled to higher ground, forced into harsher, unfamiliar terrains, they carried the terror with them. Without written language, the only way to preserve the memory of the trauma and to warn future generations of the sheer volatility of the environment was to encode it into oral tradition. A story is a highly efficient mechanism for data compression. By turning the terrifying physics of sea level rise into a narrative of divine retribution or cosmic reset, the memory could be transmitted across hundreds of generations without degrading. The details might shift the names of the survivors, the shape of the boat, but the core data packet, the sudden apocalyptic rise of the water, remained intact. The academic machine often categorizes these myths as purely symbolic or theological constructs, but to do so is to strip early humanity of its capacity for empirical observation. Our ancestors were not merely inventing stories to entertain themselves around a campfire. They were accurately recording the most devastating environmental phase transition in the history of our species. They were feeling the phantom limb. They looked out from their new, high-ground settlements at the vast, impenetrable oceans, knowing with absolute, terrifying certainty that a better, older world lay dead beneath the waves. The flood myths are the echoes of that grief, vibrating through time. But while the memory of the flood was encoded into stories, other survivors chose a different method of data preservation. They did not trust the fragility of human memory. They did not trust the spoken word to survive the grinder. They decided that the only way to ensure the data survived the next planetary deletion was to write it in the only language the Earth respects. They decided to write it in stone, and they decided to hide it. In the next run, we will leave the drowned coastlines and travel to the high, arid hills of modern-day Turkey. We will examine the moment when humanity stopped running from the sky and attempted to build a permanent record of the trauma. We will open the black box. As the meltwater pulses amputated the coastal plains and the oceans swallowed the ecological heart of the Pleistocene world, the surviving biological populations were forced upward. They retreated from the drowning valleys to the high, arid plateaus of the planet. The standard academic textbook paints a very specific picture of humanity during this transitional period, roughly 10,000 to 12,000 years ago. It classifies them as primitive hunter-gatherers, nomadic, unsophisticated bands of hominids clothed in animal skins, wielding crude stone tools, entirely at the mercy of their environment, and millennia away from understanding mathematics, architecture, or complex engineering. But when we step away from the anthropological models and examine the physical mechanics of the structures left behind on these high plateaus, the textbook narrative disintegrates. The rocks do not describe primitive nomads. They describe a highly organized, deeply traumatized species utilizing advanced engineering to survive a hostile planetary system. We begin on the Giza Plateau in Egypt. The Great Sphinx is the largest and oldest monolithic statue on Earth. Mainstream Egyptology firmly dates the construction of the Sphinx to the reign of the pharaoh Khafre, approximately 2500 BCE. This dating is largely based on contextual assumptions. The Sphinx sits geographically close to Khafre's pyramid, and a single syllable resembling Khafre's name was found on a granite stele erected between the Sphinx's paws thousands of years later. But geology does not care about contextual assumptions. Geology is the physics of erosion, and erosion is a mathematical clock. In the early 1990s, Dr. Robert M. Schoch, a stratigrapher and paleontologist from Boston University, arrived at the Giza Plateau. He was not an Egyptologist, he was a geologist. He did not look at the cultural artifacts, he looked at the limestone. Specifically, he examined the core body of the Sphinx and the massive walls of the enclosure trench from which the statue was carved. What Schoch observed shattered the accepted timeline. When wind and sand erode limestone, the standard weathering mechanism in the Sahara Desert for the last 5,000 years, they scour the rock horizontally. They create layered, parallel bands, carving out the softer sedimentary layers and leaving the harder layers protruding. The core body of the Sphinx and the walls of its enclosure do not display horizontal wind scouring. They display deep, vertical fissures, rolling coves, and scalloped indentations. In the unforgiving science of geology, there is only one mechanism capable of producing this specific pattern of erosion on limestone: precipitation. Continuous, heavy, torrential rainfall cascading down the walls of the enclosure for thousands of years. This presents an insurmountable thermodynamic problem for the textbook timeline. The Sahara Desert has been a hyper-arid, bone-dry environment for at least the last 5,000 years. To find a climate model that features centuries of heavy, relentless rainfall over the Giza Plateau, you must dial the planetary clock back past the dawn of the Egyptian civilization. You must go back to the climatic chaos at the end of the Younger Dryas and the early Holocene, roughly 10,000 to 5,000 BCE. Schoch's geological data dictates that the core body of the Sphinx was already ancient, already heavily eroded by thousands of years of rain, long before the first pharaoh ever sat on a throne. The Egyptians did not build it from scratch. They inherited a severely weather-damaged relic of the drowned world, and likely recarved the heavily eroded head to resemble their own king, which perfectly explains why the head of the Sphinx is mathematically disproportionate, far too small for its massive, leonine body. This geological dating is reinforced by the cold mathematics of archaeoastronomy. The Sphinx faces due east. If you were to stand directly behind the Sphinx on the morning of the vernal equinox in the year 2500 BCE, you would be looking at the constellation of Taurus. The alignment signifies nothing, but due to the precession of the equinoxes, the slow wobble of the Earth's axis, the background stars slowly shift over millennia. If you dial the astronomical software back to the year 10,500 BCE, right in the aftermath of the Younger Dryas trauma, the Sphinx aligns perfectly. On the vernal equinox of that era, the colossal stone lion stared directly into the rising constellation of Leo. A lion looking at a lion, locking the monument to a specific coordinate in deep time. The Sphinx is an anchor, but it is only a marker of presence. To understand the psychological terror of that era, we must leave the surface entirely and travel to the volcanic region of Cappadocia in modern-day Turkey. We must look at how the survivors reacted to a sky that had tried to kill them. Beneath the arid plains of Cappadocia lies the ancient underground city of Derinkuyu. Derinkuyu is not a cave system. It is a masterpiece of subtractive engineering. Our ancestors carved directly into the volcanic tuff rock, hollowing out a subterranean metropolis that plunges 18 stories deep, reaching 85 meters, 280 feet, beneath the surface of the Earth. The scale of the excavation is staggering. The complex contains miles of tunnels, chapels, wineries, oil presses, dining halls, and massive stables for livestock. It was designed to support a population of up to 20,000 people, along with their animals and food stores, for months at a time. It features a brilliant, multi-tiered ventilation system, a central air shaft plunging the full 85 meters down to the water table, acting as a capillary system to distribute breathable oxygen to every corner of the 18 levels. The standard academic explanation for Derinkuyu is that it was built by the Phrygians, or early Christians, as a hiding place to escape invading armies, such as Roman legions or Arab raiders. Once again, this explanation collapses the moment it is subjected to physical logic and military reality. If you are a population fleeing an invading army on horseback, you do not need 18 stories of subterranean infrastructure. 2 or 3 stories are a hiding place. 18 stories is a self-sustaining, long-term biosphere. Furthermore, from a defensive standpoint against human enemies, an underground city is a death trap. If an invading Roman legion discovers that 20,000 people are hiding beneath the ground, they do not need to fight their way down through the dark tunnels. The invaders simply need to locate the massive central ventilation shafts on the surface. They throw burning brush and toxic smoke down the holes, or they divert a river into the shafts. Within hours, the entire population of 20,000 people suffocates or drowns. An underground city is completely defenseless against an enemy that controls the surface. You do not build an 1-8-story underground city to hide from men with swords. You build an 1-8-story underground city because the surface of the Earth itself has become an uninhabitable killing machine. Derinkuyu features massive, circular stone doors, weighing up to half a ton each, stationed at strategic choke points throughout the tunnels. The crucial engineering detail of these doors is that there are no handles on the outside. They are mounted on tracks and can only be rolled shut and locked from the inside. This brings us to the most terrifying metaphor of human survival. Think about your own home. Under what circumstances do you run into a windowless room, slam a heavy door shut, slide the deadbolt, and push a heavy dresser against the wood to barricade yourself in? You do not lock yourself in a room from the inside because of a political disagreement. You do it because there is a monster roaming the hallways of your house. Derinkuyu is the ultimate locked room. Our ancestors did not carve 18 stories into the volcanic rock to hide from other humans. They were fleeing the atmospheric shrapnel of the Younger Dryas. They were fleeing the lethal, freezing temperatures of an impact winter, or the carcinogenic solar radiation of a depleted ozone layer, or the choking toxic soot of continental firestorms. They rolled those half-ton stone doors shut from the inside because the sky was murdering everything that remained on the surface. Derinkuyu is not a fortress. It is a geological coffin, built by a traumatized species desperately trying to seal themselves away from the planetary grinder. But while the people of Derinkuyu chose to hide in the dark, another group of survivors in the very same geographic region chose a different path. They realized they might not survive, but they refused to let their data be erased. In the next run, we will travel to the hilltop of Göbekli Tepe. We will examine the most important archaeological site on Earth, and we will open the black box. If Derinkuyu represents the biological instinct to hide from a hostile planet, Göbekli Tepe represents the psychological instinct to ensure that the memory of the trauma survives. Located in the southeastern Anatolia region of Turkey, perched on a high ridge overlooking a vast arid plain, Göbekli Tepe is the single most disruptive archaeological site discovered in the last century. When the German archaeologist Klaus Schmidt began excavating the site in 1996, the data he unearthed completely broke the linear timeline of human progress. He discovered a massive complex of circular stone enclosures. These were not crude piles of rocks. They were defined by massive, T-shaped limestone pillars, some standing up to 6 meters, 20 feet tall, and weighing over 10 tons. The pillars were flawlessly carved, extracted from a nearby quarry, transported uphill without the use of wheels or draft animals, and erected with precise, geometric alignment. The geological dating of these structures is absolute. They were erected around 9,500 BCE. According to the textbook paradigm, 9,500 BCE is the era of the primitive hunter-gatherer. Human beings in this region were not supposed to have discovered agriculture yet. They were not supposed to have permanent settlements, complex social hierarchies, or the surplus caloric energy required to feed hundreds of workers engaged in monumental stonemasonry. Yet, there it stands, a megalithic complex built by people who, theoretically, should only have been capable of carving small bone flutes and sharpening flint. The standard academic interpretation, struggling to fit this anomaly into the existing paradigm, labeled Göbekli Tepe as the world's first temple. The theory posits that the desire to worship gods and perform religious rituals is what drove these hunter-gatherers to invent agriculture they needed, steady food to feed the temple builders. But when you analyze the specific carvings on the pillars, and more importantly, the actions taken by the builders, the temple theory collapses into sentimentality. It fails to account for the trauma of the era. Göbekli Tepe is not a place of worship. It is a data storage device. The most crucial piece of data is found on Pillar 43, often referred to as the Vulture Stone. The pillar is heavily carved in high relief, featuring a complex sequence of animals: a vulture, a scorpion, a dog, a snake, and various abstract symbols. For decades, These carvings were interpreted as generic shamanic art, or hunting totems. But in 2017, researchers from the University of Edinburgh applied the strict mathematics of archaeoastronomy to the pillar. They realized that the animals were not random, they were constellations. The vulture stone is a star map. By running the astronomical software backward to account for the precession of the equinoxes, they discovered that the specific arrangement of the constellations on Pillar 43 corresponds precisely to the night sky, as it appeared in the year 10,950 BCE. 10,950 BCE is the exact timeline of the Younger Dryas impact event. The builders of Göbekli Tepe did not carve a generic sky. They carved a very specific timestamp. They locked the coordinates of the sky to the exact era when the world was shattered by atmospheric shrapnel and plunged into freezing darkness. Alongside the star map, the pillar features a carving of a headless man, a universal symbol of death and disaster. They were not praying to the sky. They were recording its betrayal. But the most compelling evidence that Göbekli Tepe is not a religious temple lies in what the builders did to it. After spending immense amounts of caloric energy and generations of labor to quarry, carve, and erect these 10-ton pillars, they buried them. The entire complex was not abandoned to slowly decay in the wind. It was not destroyed by an invading enemy. It was deliberately, painstakingly, and completely backfilled. The builders moved thousands of tons of dirt, rubble, and refused to bury their own masterpiece entirely underground. Why do you build a megalithic structure only to bury it? The textbook struggles with this. It suggests ritualistic decommissioning, comparing it to burying a respected elder. But if we apply the logic of survival and trauma, the answer is brutally mechanical. You do not bury a temple to honor it. You bury a structure to protect it from a planetary grinder that you know is actively hostile. Think of a commercial airliner. When an airplane is plunging toward the Earth, the cabin is a zone of absolute chaos and destruction. The structural integrity of the plane is failing. The people inside know they are not going to survive. In that moment of terminal velocity, the engineers who designed the plane do not rely on the passengers to remember what happened. They rely on the black box. The black box, the flight data recorder, is built from the most indestructible materials available. It is painted a bright, unnatural color so it stands out against the wreckage. And it is hidden in the safest, most reinforced part of the tail section. Its sole purpose is to survive the crash, preserve the data of the final moments, and wait for whoever comes to sift through the ashes. Göbekli Tepe is the black box of the Pleistocene era. The survivors of the Younger Dryas impact and the subsequent meltwater pulses knew that the surface of the Earth was a volatile, unpredictable killing floor. They had seen the sky rain fire and the oceans swallow continents. They knew that their own flesh and their own spoken memories would not survive the next iteration of the grinder. So, they encoded the data in the most durable medium available, 10-ton limestone pillars. They carved the exact timestamp of the trauma onto the vulture stone, and then, knowing that even stone can be shattered by a comet or scoured by a glacier, they buried the black box under an artificial hill. They sealed the data away, protecting it from the sky and the weather, hoping that whenever the Earth finally stabilized, whatever version of humanity rose from the dirt would eventually dig it up, read the timestamp, and understand the true, terrifying nature of the planet they inhabited. They were screaming into the future. And 11,500 years later, Klaus Schmidt heard them. We dug up the black box, we read the data on Pillar 43, we verified the dates with ice cores and nanodiamonds. The message was successfully transmitted and decoded. The problem is what we are doing with that information. We have established that the Earth deletes physical history, leaving only chemical barcodes. We have established that the sky is a kinetic weapon. We have seen how the ocean amputates continents, and how the survivors tried to warn us. Now, we must face the final, inescapable equation. We must look in the mirror. In the final run, we will take all the data from the deep past and apply it directly to the present moment. We will examine the barcode we are currently printing, and we will confront the ultimate paradox of human intelligence. We have opened the black box of Göbekli Tepe. We have read the trauma encoded in the flood myths, and we have analyzed the atmospheric shrapnel buried in the bedrock. All of this data belongs to the past, a sequence of violent planetary resets that our ancestors barely survived. But the Earth's thermodynamic engine did not stop running just because humanity figured out how to build cities. Following the chaotic climate swings of the Younger Dryas, the Earth entered a highly unusual, artificially smooth geological phase known as the Holocene. For the last 10,000 years, the global climate has been trapped in a state of freakish stability. The temperature graph flattened out. The seasons became predictable. The sea levels stopped their violent surges and settled into a gentle, rhythmic tide. This 10 millennia window of calm is the Holocene trap. Because the climate was stable, the human neurological system, which operates on immediate, short-term pattern recognition, was deceived. We forgot the trauma of the Pleistocene. We forgot that the sky could fall and the oceans could amputate continents. We looked at the stable, temperate world around us and arrived at a deeply arrogant, biologically flawed conclusion. We believed that the Earth was a static, passive garden designed specifically for our expansion. Operating under this illusion, the human species shifted from being a mere participant in the ecosystem to becoming a planetary-scale geological force. We discovered the vast, subterranean vaults of fossilized solar energy coal, petroleum, and natural gas. These were not gifts from the Earth. They were the compressed, liquefied corpses of hundreds of millions of years of ancient biology, locked away in the deep crust to maintain the planet's carbon equilibrium. When the first steam engine was ignited, humanity did not just start an industrial revolution. From the perspective of thermodynamics, we triggered a mass exhumation. We began digging up the biological dead, pumping them to the surface, and vaporizing them into the atmosphere at a rate that defies all natural geological processes. The data confirming the scale of this exhumation is absolute. It is tracked by the Keeling curve, a daily record of global atmospheric carbon dioxide concentrations measured from the pristine, high-altitude air of the Mauna Loa Observatory in Hawaii. For the entirety of human civilization, from the building of Göbekli Tepe to the fall of the Roman Empire, right up until the dawn of the 19th century, the atmospheric concentration of carbon dioxide hovered steadily around 280 parts per million ppm. It was the baseline operating parameter of the Holocene. Today, that number has breached 420 parts per million. To the untrained ear, 420 parts per million sounds microscopic. It sounds like a statistical rounding error, but in the fragile mechanics of atmospheric physics, it is a deafening siren. We have increased the total volume of carbon dioxide in the Earth's atmosphere by 50% in less than 2 centuries. The sheer velocity of this injection is unprecedented in the last 800,000 years of ice core records. We are pumping carbon into the sky at a rate estimated to be 10 to 100 times faster than the natural volcanic outgassing that routinely shifts the planet's climate over millions of years. By injecting this massive volume of insulating gas into the closed system of the atmosphere, we have increased the amount of solar radiation trapped against the planet's surface. We are force-feeding kinetic heat into the planetary engine, and the grinder is waking up. The Earth is a self-regulating system. When you force a system out of equilibrium, it does not sit idle. It activates autonomous mechanisms to process the excess energy. Climatologists call these positive feedback loops. Once triggered, these loops operate entirely independent of human action, accelerating the phase transition whether we stop burning fossil fuels or not. Look at the Arctic. For millions of years, the northern ice cap has acted as the planet's shield, reflecting up to 80% of incoming solar radiation back into space, a phenomenon known as the albedo effect. But as the atmospheric temperature rises, the white ice melts, exposing the dark, absorbing waters of the Arctic Ocean beneath. The dark water absorbs the sun's heat instead of reflecting it. The ocean warms, the warmer water melts more ice, the shield dissolves faster, the loop closes, and the engine accelerates. Simultaneously, look at the Siberian and Canadian permafrost. Buried beneath millions of square miles of frozen tundra are billions of tons of ancient, undecayed, organic matter. As the Arctic warms at 4 times the rate of the rest of the globe, this permafrost is thawing. The microbes trapped in the soil are waking up, metabolizing the ancient flora and outgassing methane, a greenhouse gas, with a warming potential more than 28 times greater than carbon dioxide over a century-long timescale. We are no longer just pushing the boulder up the hill. The boulder has crested the peak, and gravity is taking over. The autonomous thermodynamics of the Earth are engaging to process the energy spike. The social and academic narrative surrounding this data is saturated with morality. Politicians, activists, and documentaries frame this 420 ppm reality as a tragedy. They call it a failure of human ethics, a result of corporate greed, and a betrayal of the natural world. They demand guilt. They demand that we feel the weight of our ecological sins. But the scanner does not care about morality. The laws of physics do not register guilt. When you strip away the human emotion and analyze our modern atmosphere through the cold, unfeeling lens of a mass spectrometer, a terrifying symmetry is revealed. Remember the barcode of the Paleocene-Eocene thermal maximum. 56 million years ago, the Earth suffered a massive, rapid injection of carbon that spiked global temperatures, acidified the oceans, and caused mass extinction. We established in Chapter 2 that this ancient carbon carried a very specific, undeniable chemical fingerprint. It was isotopically light. It was overwhelmingly composed of carbon, 1,2, the exact atomic signature of burned biological material. Now, let us examine the chemical barcode we are printing today. When we extract coal and oil from the ground, we are extracting the bodies of ancient plants and microorganisms. Because they were once alive, they are heavily enriched in carbon, 1,2. When we burn them in our power plants, our jet engines, and our internal combustion cars, we are vaporizing that ancient biology and venting it directly into the atmosphere. Consequently, atmospheric chemists monitoring the current surge in CO2 have observed a continuous, aggressive plunge in the atmospheric ratio of carbon, 1,3 to carbon, 1,2. The air we are breathing right now is becoming isotopically lighter every single day. The exhaust of our industrial civilization is not a unique, modern phenomenon. It is a precise atomic replica. The chemical fingerprint of the 420 ppm atmosphere of the 21st century matches the chemical fingerprint of the 5-6 million year old PETM boundary layer with 100% accuracy. The sheer volume of the carbon injection, the extreme velocity of the release, the exact carbon 1,2 biological signature, the subsequent activation of methane and albedo feedback loops, all of the parameters are perfectly aligned. We are not writing a new chapter in the history of the Earth. We are executing a flawless, mechanical reenactment. If you were to take the chemical barcode being written by humanity today and lay it directly over the barcode found in the ocean sediment from 56 million years ago, the black and white stripes would align perfectly. But there is one final, devastating difference between the ancient event and our modern reality. In the final run, we will confront the true nature of human intelligence, stripping away the illusion of our own agency and discovering the cold liberation that lies at the end of the equation. When confronted with the data, the spiking Keeling curve, the 420 ppm atmosphere, the exact replication of the 5-6 million year old Paleocene-Eocene thermal maximum barcode, the standard human reaction, is a profound sense of moral failure. We are bombarded daily with a narrative of ecological guilt. We are told that humanity is a virus. We are told that our greed, our corporations, and our relentless desire for consumption are an aberration, a tragic flaw in the human character that has corrupted the pristine garden of the earth. The planetary grinder does not care about your guilt. The laws of physics do not operate on morality. To understand what is truly happening to our planet, we must strip away the emotional narrative and look at the human species through the cold, objective lens of thermodynamics. Specifically, we must examine the second law of thermodynamics, the universal law of entropy. The second law dictates that, in any closed system, energy must disperse. Order must inevitably decay into disorder. Concentrated energy must be spread out. For hundreds of millions of years, the Earth actively violated this principle on a localized scale. During the Carboniferous period, massive, dense forests covered the continents. These plants absorbed unimaginably vast amounts of kinetic solar energy, converted it into biological tissue, and then died. But because the specific microbes required to decompose that dense wood had not yet evolved, those forests did not rot. They were buried intact under millions of tons of mud and rock. The Earth became a colossal battery. It hoarded concentrated solar energy in the form of subterranean hydrocarbons, coal, oil, and natural gas. It locked billions of tons of carbon, 2, into the dark crust, creating a massive, unnatural imbalance of potential energy. But the universe does not tolerate concentrated energy indefinitely. It requires a mechanism to release it, to oxidize it, and to disperse it back into the void. It requires a spark. This is the great, terrifying paradox of human intelligence. We flatter ourselves by believing that our hyper-advanced brains evolved to compose symphonies, to paint masterpieces on chapel ceilings, to formulate philosophy, and to explore the cosmos. We believe our intelligence is a divine spark or a miraculous evolutionary pinnacle. It is neither. Human intelligence is simply a highly efficient biological algorithm designed to locate, extract, and ignite stored carbon. We are not the masters of the Earth, we are the catalyst species. Look at our industrial history not as a sequence of political empires, but as a thermodynamic chemical reaction. Evolution produced a bipedal primate with opposable thumbs and a frontal lobe capable of abstract mathematics, perfectly suited to invent the internal combustion engine, the deep water drilling rig, and the global supply chain. We did not build these machines because we are evil. We built them because we are the universe's chosen mechanism for discharging the Earth's battery. When you drive your car to work, when you turn on the lights in your home, when you order a package that is flown across the globe on a jet burning thousands of gallons of kerosene, you are not committing a moral sin. You are behaving exactly as a chemical enzyme behaves when introduced to a substrate. You are doing what a match does to a dry forest. You are blindly, perfectly fulfilling your biological and thermodynamic function as a catalyst species. We are the entropy engine. And if we follow this biological programming to its natural, mathematical conclusion, we already know exactly how the equation ends. We have seen the barcode. The engine will continue to burn. The feedback loops, the melting albedo shield of the Arctic, the venting methane of the Siberian permafrost will accelerate beyond our capacity to measure them. The global temperature will spike, pushing the biosphere beyond its thermal equilibrium. The agricultural systems that sustain 8 billion apex predators will collapse under the weight of hyperdroughts and flooded coastlines. The human population will be systematically deleted by the very environment it was programmed to ignite. And 50 million years from today, everything we ever were, every war we ever fought, and every person you ever loved will be compressed into a mute, 2 millimeter thick chemical sediment in the bedrock. A sudden spike in carbon 1-2, a brief, unexplained geochemical anomaly. The Earth will take 200,000 years to scrub the carbon from the sky, cool the oceans, and reset the thermostat. The planetary grinder will fall silent, and the cycle will begin again. In astrophysics, there is a concept known as the Great Filter. It was proposed to answer the Fermi paradox. If the universe is infinite, why is it so quiet? Why haven't we found any other intelligent life? The Great Filter theory suggests that there is a specific, highly probable evolutionary stage that almost no civilization can survive. A barrier that acts as a universal executioner. The barcode in the rock is our Great Filter. It suggests that intelligence is a self-terminating loop. A species becomes intelligent enough to harness the planetary battery, but remains too biologically primitive to stop itself from burning the battery until the biosphere incinerates. 99.9% of all civilizations in the cosmos likely fail this test. They become silent, 2 millimeter barcodes on dead worlds. If we surrender to our programming as an entropy engine, that is our destiny. It is mathematically assured. But there is a glitch in the Earth's programming. The planetary system created a catalyst species to burn its carbon, but it made our intelligence slightly too powerful. It gave us the capacity to build mass spectrometers. It gave us the orbital radar to see through miles of glacial ice. It gave us the titanium drills to pull sediment cores from the abyss. We are the first species in the 4-5 billion year history of this planet to actively observe the grinder in motion. The builders of Göbekli Tepe were terrified of a sky they did not understand. The victims of the meltwater pulses drowned in a flood they could not predict. They were blind victims of a violent universe. We are not blind. We have dug up the black box. We have translated the scratches on the wall. We have mapped the shattered glass on the highway, and we have read the ancient barcode of the PETM. We are the first entities on Earth to possess the exact coordinates of our own deletion. This awareness is the only force in the universe capable of breaking the second law of thermodynamics. The Great Filter is not an execution mandate. It is the ultimate intelligence test. Are we just a dumb biological algorithm, blindly maximizing energy consumption until we burn our own petri dish to ash? Or are we a species capable of defying our base evolutionary programming? Can we look at the thermodynamic cliff edge, recognize it, and make the conscious, unprecedented decision to turn the wheel? The answer to that question is being written into the sediment right now. The concrete of our modern barcode has not yet cured. The black box from 12,800 years ago has been opened, and the data is in your hands. If you look away from this reality, if you assume that the academic machine or the political establishment will slowly solve this problem, you are choosing to be an enzyme. You are choosing to let the grinder do its work. But if you understand the sheer, terrifying weight of the physical evidence, if you realize that we are standing on the exact same threshold that broke the world 56 million years ago and 12,800 years ago, then you have a responsibility to the future. The survivors of the last catastrophe moved 1 0-ton blocks of limestone to leave a warning for us. You do not need to carve stone. You only need to transmit the signal. You need to shatter the illusion of the Holocene trap for everyone around you. You need to force this conversation into the light. Share this data. Spread the coordinates of the black box. Wake up the rest of the catalyst species before the thermal inertia becomes unstoppable. We are facing the final exam of the Earth. Do not let humanity's final answer to the universe be a silent, anonymous barcode in the rock.